I am Aiden Tat. Today I'll be presenting to you the different focus sequences in structural engineering. So first off, we have the civil structures focus sequence. And this focus sequence is all about designing the frameworks that support our built environment like bridges, buildings, dams, tunnels, offshore platforms, and other major infrastructure. It's needed because nearly every part of society relies on structures that can safely carry loads, resist earthquakes and wind, and last for decades. Engineers in this field constantly confront questions like, how does structure behave under extreme forces? Where are the weak points? How do we strengthen older systems to modern safety standards? Typical projects involve modeling load paths, analyzing how materials respond to stress, and ensuring a structure meets code requirements. Common problems in civil structures include predicting how structures deform under complex loading, preventing failures, and designing systems that are safe but also efficient and cost-effective. Engineers often work on seismic retrofits, evaluations after natural disasters, or optimizing new designs using simulation tools. Career paths from this focus include structural design, analysis and modeling, seismic retrofit engineering, field engineering on construction sites, and forensic engineering. Following that, what is the geotechnical engineering focus sequence? Well, this focus sequence is about understanding soil, rock, and groundwater so it can build safely on or in the ground. It's essential because foundations, dams, slopes, tunnels, and pavements all depend on how the subsurface behaves. Types of questions that geotechnical engineers may ask include, how deep can I excavate before needing support? How fast can I drain a dam without risking failure? Engineers use soil exploration drilling, lab tests, and limited data to make these critical decisions. So what problems may you encounter as a geotechnical engineer? Well, engineers must understand soil composition, solid particles, water, air, and cementation, and they have to account for variability between field and lab conditions. They analyze settlement and evaluate stability in dam slopes. A major historical example is the 1971 Lower San Fernando Dam failure, where an earthquake caused a saturated foundation soil to lose strength through liquefaction. The dam nearly collapsed, and this event reshaped U.S. dam safety and geotechnical design standards. Next, we have the aerospace structural focus sequence. And this focus sequences focus on designing the structures of aircraft, spacecraft, and UAVs so they can withstand the forces they experience in a flight. Engineers analyze the balance between lift, weight, thrust, and drag and determine how these loads travel through parts like wings and control surfaces. This field is essential because aerospace vehicles must be extremely lightweight yet strong enough to perform safely at high speeds and under harsh conditions. Problems aerospace structural engineers may encounter are related to how aircraft and spacecraft handle loads during flight, determine how wings, fuselages, and control surfaces respond to lift, drag, thrust, and weight. They also address issues like vibration, buckling, and how to keep structures lightweight without sacrificing safety or performance. Career paths include working in aircraft and UAV design, spacecraft and launch vehicle structures, satellite systems, and defense and aviation companies. Many engineers go into organizations like Boeing, NASA, the US Navy, and SpaceX, while others can apply structural and composite knowledge to automotive systems, marine vehicles, sporting equipment, or high-performance medical devices. Next, what is the SHM/NDE focus sequence? Well, the structural health monitoring and non-destructive evaluation focus sequence is about evaluating the condition of structures without damaging them. Engineers in this field develop sensing systems, data acquisition methods, and diagnostic tools that detect cracks, corrosion, and other forms of deterioration. There's a major need for this discipline because many bridges, buildings, aircraft, and other infrastructure systems age over time, where traditional visual inspections are slow, costly, and sometimes risk hidden damage. SHM and NDE engineers address challenges such as detecting internal cracks, measuring vibration patterns, identifying corrosion, distinguishing between harmless noise and real damage, and interpreting large amounts of sensory data with uncertainty. They design sensing networks, wired or wireless, and develop algorithms that can automatically diagnose the health of a structure. A major case study is the Gwedaang Bridge in Korea. This bridge was used to test large-scale wireless sensor networks on a real concrete box girder structure. Engineers installed multiple nodes to monitor vibration, environmental effects, and long-term performance. The project demonstrated how wireless monitoring can reliably track structural health while reducing inspection time and cost, showing the potential of SHM systems for future bridge management. So lastly, what is my most interesting focus sequence? Well, to me, the civil structure focus sequence interests me the most because I love understanding how buildings and bridges stay standing. The combination of materials, loads, and real-world problem solving makes it the most exciting and impactful field to me.